Welcome to the deep dive. Ready to explore some fascinating AI concepts?
Always up for a good AI deep dive.
Okay, excellent. So today, we're going to be diving into symbolic AI.
Oh, a classic.
Yeah, a classic approach. We'll be drawing insights from a great essay by Jörg-Owe.
Schneppet, yeah, he lays it all out really well.
He does. So symbolic AI, it might sound like robots talking in code or something, but it's not that complicated.
Right, it's more like teaching a computer to think, but using our language.
Using symbols and rules?
Exactly, it's like building with logical Legos.
I like that, logical Legos.
Yeah.
So instead of just drowning a computer in data and hoping it figures things out.
Right, the throw spaghetti at the wall method.
Exactly. We're actually giving it a set of rules, like a framework.
It's a more structured approach.
And that structure relies heavily on something called knowledge representation.
Ah, yes. Knowledge representation, the heart of symbolic AI. It's about creating a blueprint of knowledge that a computer can actually grasp.
Okay, so how do we do that? How do you represent knowledge in a way a computer can use?
Well, there are a few key methods. One is semantic networks. Imagine a giant web of interconnected concepts.
Like a mind map.
Kinda, but way more complex. Each concept is a node in the web, and the links between them show relationships.
So it's showing how different ideas connect.
Right. Then we have frames. Think of these as digital fact sheets.
Fact sheets for what?
For objects or events. They have slots for attributes and values.
So like if the concept was cat, you'd have slots for color, breed, size.
Precisely. It's a way to organize information about the world in a way a computer can digest.
Okay, so we've given the computer this structured information, but how does it actually use it to, solve problems?
That's where reasoning and inference come in. Symbolic AI uses different styles of reasoning. One of the most fundamental is deductive reasoning.
Deductive reasoning, like Sherlock Holmes.
Exactly. You start with known facts and use logic to arrive at a conclusion.
It's like the computer's playing detective.
Right. Think of those medical diagnosis systems. If the system knows if symptom A and symptom B then likely condition C, it can use that logic to make a diagnosis.
So it's really applying logic to real-world problems.
That's the power of symbolic AI.
That's incredible. But deductive reasoning isn't the only tool in the box, is it?
Of course not. There's also inductive reasoning. That's where the system learns from examples.
Ah, so it's more like a scientist observing patterns.
Exactly. And then we have abductive reasoning, where the system tries to find the best explanation for what it observes.
So there are different ways the AI can reason its way to a solution.
That's right.
One thing Schneppet mentions is this idea of common sense reasoning.
Ah, yes, common sense. The holy grail of AI.
Why is it so hard to teach computer common sense?
Because it's all about those unspoken assumptions we humans make.
Like knowing water is wet.
Exactly. Things that seem obvious to us are incredibly difficult to explain to a machine.
It's like trying to explain a joke to someone who doesn't understand your culture.
It's one of the big challenges facing symbolic AI, capturing that human intuition.
Right, because the real world is full of nuance.
And that's where a purely symbolic approach might struggle.
Okay, so we've got the basics down. Now I want to rewind a bit. Where did this all begin? Where does symbolic AI come from?
Well, the early days of AI were a time of tremendous excitement. We call it the first AI summer.
When was this?
From the late 40s to the mid-60s, there was a surge in AI research.
Focusing on symbolic methods.
Right. And a big development during this time was the rise of expert systems.
I've heard of those.
Yeah.
Like AIandEthics that could diagnose infections.
Yeah.
And Dendrol, the chemistry expert system.
Yes, those are great examples, especially Mycian. It was revolutionary, using a rule-based system to analyze symptoms and suggest treatments.
Like a digital doctor.
In a way, yeah. And these early successes really fueled optimism about the future of AI.
But as research went on, some limitations of symbolic AI started to emerge.
They did.
What were they?
Well, one was scalability. As data sets grew, symbolic AI systems started to struggle.
It's like trying to build a skyscraper with only Legos.
It just doesn't scale well.
And I imagine that ties into the common sense issue too, right? The more complex the world, the harder it is to capture it all in rules.
Exactly. Plus, there was the problem of adaptability. Symbolic AI is great at following rules, but not so great at learning from experience.
Like those old GPS systems that would send you off a cliff if the map was wrong.
Exactly. They lacked that ability to adapt.
So these challenges led to some debates within the AI community.
Oh yeah, like the neats versus scruffies debate.
That's a great name for a debate.
It was all about those who favored logic and rules versus those who wanted more flexible, data-driven approaches.
A clash of philosophies.
You could say that. And it definitely shaped AI research.
But even with these controversies, symbolic AI has clearly left its mark.
Absolutely. It's a foundation for many of the AI applications we use today.
Okay, so we've got the historical context. Now, where is symbolic AI actually used in the real world?
Well, one area is natural language processing, NLP.
So things like chatbots, machine translation.
Exactly. Symbolic AI helps computers make sense of human language.
And human language is messy, full of nuance.
Right, but symbolic AI can handle that. It's good with ambiguity and context.
Like giving the computer a set of linguistic rules to decipher our meaning.
You got it. And while newer approaches like deep learning have made huge strides in NLP,
Right, everyone's talking about deep learning these days.
symbolic AI still has a lot to offer, especially for tasks that require logic and knowledge representation.
It's not about one replacing the other, but finding the best tool for the job.
Exactly. And that leads us to one of the most exciting areas, neurosymbolic AI.
The best of both worlds.
Right. It combines symbolic AI with neural networks.
It's like combining Spock's logic with Data's learning ability.
That's a great analogy. It's all about creating more powerful and adaptable AI systems.
So even with all the buzz about neural networks, symbolic AI is still relevant.
Absolutely vital. It's a foundational approach that continues to shape the field.
Well, this has been a great overview of symbolic AI, but we're just getting started. We'll be back in a moment to continue our deep dive.
Welcome back.
Okay, so we've covered a lot of ground with symbolic AI, but now it's time for,
The reality check.
the reality check. Because like you said, no technology is perfect.
Definitely not. Every approach has its strengths and weaknesses.
So what are some of the limitations of symbolic AI? Where does it fall short?
Well, one of the biggest hurdles is scalability.
Scalability, you mean like handling lots of data?
Exactly. As the volume of data grows, symbolic AI can really struggle.
Because it relies on those handcrafted rules.
Yeah, it's like imagine trying to manage a library with millions of books, but you're only using index cards.
That'll be a nightmare.
A total nightmare. And it's not just the amount of data, but the relationships between data points. It gets really complex.
And that complexity can trip up symbolic AI.
It can. And then there's adaptability, or rather the lack of it.
We touched on that earlier. Symbolic AI is good at following rules, but not so good at learning from experience.
Right. It's like if you tried to teach a computer to ride a bike by giving it a set of instructions.
It might know the steps, but actually balancing.
That's a whole other level. It needs to adapt to the environment, the terrain, and symbolic AI often struggles with that.
Like those self-driving car videos where the car just freezes because it encounters something it wasn't programmed for.
That's a great example. Real-world scenarios throw curveballs all the time, and symbolic AI systems need to be able to adapt.
And then there's that constant challenge of common sense, right? Like we talked about. It's so hard to program all those unspoken assumptions we humans have.
Oh, common sense. The bane of AI developers everywhere. It seems so basic to us, but it's incredibly complex.
It's like explaining sarcasm to a computer. It's more than just the words themselves.
Exactly. It's about context, tone, shared understanding. And that's where symbolic AI, with its reliance on explicit rules, hits a wall.
So does that mean we need to ditch symbolic AI and move on?
Not at all. It just means we need to be aware of its limitations.
And find ways to address them?
Precisely. One way is by combining symbolic AI with other approaches.
Like with neurosymbolic AI, that hybrid approach.
Exactly. It's about leveraging the strengths of both worlds.
Symbolic AI brings the logic and explainability.
And neural networks bring the learning and data handling capabilities.
So it's like a true partnership.
It is. And that's how we can overcome some of those limitations and build more powerful AI systems.
You know, it's interesting. We've been focusing on the technical side of symbolic AI, but it also raises some pretty deep philosophical questions.
Oh, absolutely. As AI systems become more complex, we can't ignore the ethical and philosophical implications.
Like one thing that Schneppat talks about is this question of whether machines can truly think like humans. Can they ever be conscious?
Ah, the big question. It's something philosophers have debated for centuries.
And now AI is bringing it to the forefront.
It is. And while we don't have definitive answers, AI can give us a new perspective on consciousness and intelligence.
It makes you think, what does it even mean to think?
Exactly. As we develop AI that can reason and make decisions, these questions become even more relevant.
It's a reminder that AI isn't just about technology, it's also about understanding what it means to be human.
Well said. And as we grapple with these big questions, we also need to consider the impact of symbolic AI on society.
The societal impact.
Yes. As AI becomes more integrated into our lives, we need to think about the ethical implications.
Because any powerful technology can be used for good or for bad.
Precisely. We have a responsibility to ensure that symbolic AI is used ethically.
To benefit humanity.
Exactly. We need to have those tough conversations about ethics and values and involve everyone, not just the tech people.
So it's a collective responsibility.
Absolutely. And looking ahead, one of the big areas of focus for symbolic AI is explainable AI, or XAI.
Explainable AI. Haven't heard that term.
It's all about making AI systems more transparent so we can understand how they reach their conclusions.
So it's not just about the AI making a decision, but also being able to explain its reasoning.
Right. Imagine you get a medical diagnosis from a computer, but you have no idea why it came to that conclusion.
That would be unsettling.
To say the least. XAI aims to address that, especially in areas like healthcare and finance, where trust is essential.
So it's about making the black box of AI more transparent.
Exactly. And this is where symbolic AI can really shine because it's inherently more explainable than other approaches.
So it's about leveraging that strength to build AI systems that are both intelligent and trustworthy.
That's the goal. And I think we'll see a lot more emphasis on explainable AI in the future.
So symbolic AI, even with its limitations, has a lot to offer.
Absolutely. It's a fascinating field with a rich history and a promising future.
Well, this has been a really insightful look at the complexities of symbolic AI. But before we wrap up, I think it would be good to take a step back and recap some of the key takeaways from Schneppat's essay. All right, so as we wrap up our deep dive into symbolic AI, let's circle back to Schneppat's essay.
Yeah, good idea. Let's distill some of those key takeaways.
Okay, so we started by defining symbolic AI. That whole idea of using symbols and rules to teach computers to think.
Right. It's like giving them a language of logic.
And we talked about those methods for representing knowledge, like semantic networks and frames.
It's like creating a blueprint of information.
So the computer can make sense of it all.
Exactly. And then those different reasoning styles, deductive, inductive, abductive.
It's amazing how symbolic AI can apply those reasoning styles to solve real problems.
Right. Like those early expert systems, MyCIN and Dendrol, that was a big moment for symbolic AI.
It showed the world what this approach could do.
Absolutely. But we also talked about those challenges, those limitations that symbolic AI faces.
Scalability, adaptability, the old common sense conundrum.
Yeah, that's the tough one. Teaching a computer to understand those things we humans just get.
It's like, how do you explain intuition to a machine?
Exactly. And that's why it's so important to explore other approaches, to find ways to complement symbolic AI's strengths.
Like with that hybrid approach, neurosymbolic AI.
Right, combining the best of both worlds, logic and learning.
And then those philosophical questions that symbolic AI raises.
The big ones, like, can machines truly think? Can they be conscious?
Those questions get to the heart of what it means to be human.
They do. And as we develop more sophisticated AI, we can't shy away from those ethical considerations.
It's our responsibility to ensure that AI is used for good, to benefit humanity.
Couldn't agree more. And Schneppat reminds us that even with those limitations, symbolic AI is still a powerful tool.
It's a testament to the power of logic and reasoning, even in this age of data and algorithms.
Well said. So as we wrap up our symbolic AI deep dive, let's leave our listeners with something to ponder.
If you could teach a computer just one piece of common sense, what would it be and why?
It's a great question, and it underscores the ongoing challenge of bridging the gap between human intuition and artificial intelligence.
So keep exploring, keep questioning, and keep learning about this incredible field. There's always something new to discover in the world of AI.
That's the beauty of it. It's always evolving.
And that's a wrap for the deep dive. Thanks for joining us.
Until next time.